well, good morning, everyone. Well, welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 8 is on the screen. Number 1 is to simplify. Numbers 2 and 3 to solve. Let's see how you do with those. By now, they should be a piece of cake. You have about 5 minutes. 5 minutes. You started, please. All right, let's see. Number 1. Elijah, get us started, please. What'd you get for number 1? For number 1, A equals 6. Okay. So, if you notice, number 1 is to simplify. That means it's just an expression. There are no equal signs. So we just need to simplify. Help them out. Madison, go. Okay, but what's the answer? Well, what's negative 2a, negative 2b, plus 6. Hands, have you got that in any order? In any order? Yeah, we got it. Okay. Not bad. All right. Let's go to number 2. For number 2, what'd you get for number 2, Angel? A equals what? 2. I was about to say, I'm like, did I make a mistake? Negative 2. Hands, have you got that? That is correct. Woo. Okay. All right, and number 3, common denominator, everyone? 6. Distribute. That gives us 18 over 2x plus 6 over 3, less than or equal to 6 over 6. And this is 9x plus 2, less than or equal to 1. From there we do minus 2 minus 2. We got 9x less than or equal to negative 1. And at the end divide by 9. Therefore x is less than or equal to negative 1/9. Why didn't I flip it? Tell your neighbor, please. Yeah. All right, copy the agenda for today. Here we go. Warm-up number 8. We're still with compound inequalities. Today we finished that. Yesterday I was running a little bit short on time, so we're going to finish the second part today. And we only have 10 problems for tonight. It's a play sheet. Only 10. No, it's not 10. Only 10. Pretty good, right? Right? Yeah. I remember when I was in high school, we had, they changed my schedule, so I had PE the last period of class of the day, and they did that on purpose because I was in the football team, so we used to start practice 7th period, then stay after school for another 3 hours, so the 2 hours were just weightlifting, and the last portion we would go and run bleachers. You guys know what that means? Like up and up, downs and stuff. And then at the end, the coach was off. All right, guys, let's just run 2 miles only to close our practice. Only? by the time I was on my 3rd lap, I didn't feel my legs with all the practice we had done. I'm serious. They wanted us to close with 8 turns for our 3-hour practices. Ain't that crazy? Woo! Anyways. All right, we got this? Yes? All right, today there is no Nearpod code. Last night's home play, now check this out, look up to the screen. Last night was done on purpose so that you can review your inequalities. Have we been doing these? Yes. How about that? Yes. How about this one? Yes. This one's just combine here and then solve, yes? Okay. The one I think might have given you problems was number 4, because we didn't really get to that one. We just did one, like, very kind of like expeditiously. Today we're going to focus more on finishing those. And also we didn't get to the elaborate on the graphs. Now, I left you those just so that you can dig through your noodle and see if you remember. But for sure you should have done numbers 1, 2, 3, and 5. Is that correct? Yes, because we did those in class. Okay. That's my gift from me to you, your practice, yes. Tonight it's only a play sheet with 10 problems only. All right. So before I move on, let me show you how to get this play sheet because you need it, right? All right. So get your Chromebooks out, please. And I'm going to pause the video at this time. All right. So our objective for today, I can solve one variable equations and inequalities. We're still on these. We're hammering these out. And we're going to finish off the week with this concept. But I'm adding more rigor. I don't know if you noticed, little by little, yes? And hopefully by Friday, we'll be done with our Algebra 1 review. And next week, we're going to dive right into Algebra 2. Let's go bring it, okay? So with that said, though, in order to keep organized, we already know, let me show you really quick your Cornell note. The Cornell note should look something like this. Here's your paper. Your objective goes down here. Objective. All right? And right here, what I want you to do whenever we start a new concept or a new session, I want you to write whatever it is we're working on. So like that, you can go easily to your notes when I ask you that we're going to have a pop part A on these 3 things. Then you already have the title. So today we're going to be focusing on compound inequalities. Compound inequalities. We started already yesterday, but today we're really going to hammer this concept out and hopefully get rid of some doubts from last night. Okay? Okay, we good? All right, here we go. So, we know that our concept is one variable equation and inequalities. You don't need a Freire model. You already have all this. We know the examples, non-examples. We talked about the 4 steps: simplify, isolate, plot, and check. And then on the next screen, it was a blank screen, and I gave you 2 examples just on linear inequalities. We did the graphing and the solution set. Okay? From there, we got into, I said, a quick review on the inequalities, and this is how they're graphed. And this is another one. And then I said, when I combine both of them, that's what we call a compound inequality. What is it? Compound. And that's when combining this one with this one, and all of a sudden we end up with a compound inequality. We've been working with these. So we did in class this one, yes. Then we did this one, yes. And then I really moved on to the next, but I wanted to spend a little bit more time on this to get some practice. Copy this one, example number 3. Example 3. And it reads, 8 less than 3x minus 1 less than or equal to 11. All right, so let's do this one together. And once again, I'm going to be using 2 different colors for the graphing and also my 4 different colors to be solving and such. So make sure you have that ready. Here we go. So line down the inequality symbols. All right, so I'm going to start with blue. Can I simplify the left side? No. How about the middle? No. How about the right side? No. Therefore, to start solving for x or leave x by itself, what do I do here? Everyone, add 1. So whatever we do here, we do to all sides. Add 1, add 1, add 1. This is 9 less than 3x. This cancels, and less than or equal to 12. All right? Are we doing up to right there? Good. All right, but we still need to leave x by itself. Look at it. Therefore, Nayeli, what do I do next? Divide 3 to all sides. All sides. Divide 3, so this is 3 less than x less than or equal to 4. All right, let's graph this. Make a straight line over here on the side. Man, look at that. Pretty straight, huh? All right, now look, both of these numbers are positive, so I'm going to move my 0 over to the left so I can have space over here for my positive numbers. So here we go. I'm going to do the right side of this compound in green, so look up. The right side is from the X and on. I'm going to do that in green. So what's my dividing point? 4. So I'm going to start at 4. Is it an open or closed point? Close because it has the equal sign, so I'm going to do a solid point. All right? Next, I'm going to test a point or a number on the line to see if it's true, and if it is, I'm going to shade towards that. So I'm going to test 0. So instead of X, I'm going to substitute 0, and then I'm going to bring down the less than or equal to 4. So let me read it. Is 0 less than 4? Yeah, that's true. So that means I'm going to shade towards the 0 because that's part of the solution. All right, I'm going to switch to blue now, and I'm going to do the other half of the inequality. Bless you. There it is. What's my dividing point now? 3. So I'm going to plot 3. Is it an open or closed point? Look at the inequality. Open, so you just do an open point. And then I'm going to test the number again. I'm going to test 0. Yeah, here it goes. So instead of X, I'm going to substitute 0. Bring down the inequality symbol and the 3. Let me read it. Is 3 less than 0? No, that's false. That means I don't shade towards the 0. I shade in the opposite direction. All right? And then at the end, we write our solution set. Solution set of X such that, now here you go, in case some of you got lost. You write your first dividing point, which is 3. The other one is 4. You write the variable in between, and then arrows between those two to the left. And then check which one is a solid point. Which one was our solid point? The 4, so we put a little equal sign on that one, and then you close your bracket. Yes? Pretty good? All right? So I did one. Now you're going to do one by yourself. Yes? Let's see how you do with number 4. Copy this one. Example 4. All right. We got -4 less than or equal to 3n plus 5 less than 11. Copy that, and I'll give you some time for that one, and then we'll share with your neighbors. So give you some time. Copy and go. All right, let's see. Oh, I forgot to do this. There you go. All right, get it started, please. Starla, what do I do first? What did you do first? Subtract 5, subtract 5, subtract 5. So we end up with -9 less than or equal to 3n. This cancels. Less than 6. Man, Starla's in a row. Let's go. Next. Mia, go. What do I do next? Divide by 3, divide by 3, divide by 3. -3 less than or equal to n less than 2. Hands, have we got that? Yeah, we got this. All right, let's graph this. Straight line over here. Bam. And let's see. We do have opposite numbers. Okay, so I start with 0 here. So once again, I'm going to use green for the right side of the compound. Let's see. What's my dividing point? 2. Open or close point? Open. I'm going to test 0. Is 0 less than 2? Yes, I'm going to go towards 0 because this is true. All right, next I'm going to use blue for the second half. So -3 is right there. Is it an open or close point? Closed. All right, I'm going to test 0 again. 0. And it reads -3 is less than 0. Is -3 less than 0? Yes, so I'm going to use and go towards 0 because this is true. And that's my graph. Let's write our inequality solution set of n such that -3, then our other one is 2, and then in between you write the n, arrows to the left, and which one has a solid point? The first one, and there you go. Hands if you got that. All right, from 1 to 5, how comfortable do you feel with these? Yes, 5, 4, 5, that's okay. All right, one more, or are we good? One more, just to solidize this one, all right? Not that one. Yeah, let me give you an example. Let's do example Shazam Q, all right? Let's do, not that one. Let's do 45 less than or equal to 2Q minus 1 less than negative, give me a number? All right, 7. All right, let's see how you do with that one. Ready and go. All right, let's see what we got. Get us started, please, Leon. What do I do? Add 1 to all sides. Add 1, add 1. We got 46 less than or equal to 2Q less than -6. Continue, Andrea. Divide by 2, divide by 2, divide by 2. We end up with 23 microjoules. And then Q less than -3. Hands if you got that. All right. Let's graph this. Nice straight line over here on the side. Let's see. 0. I'm going to start with green for the right side of the compound. We got -3 right there. Is it an open or closed point? Open. I'm going to test 0. Is 0 less than -3? No, that's false. So I'm not going to go towards 0. I'm going to go in the opposite direction. All right. And then we got this part, which is 23 microjoules. Close point. I'm going to test 0 again. So 0. Is 23 less than or equal to 0? No, that's false. So it's going to go the opposite direction. There it is. Hands if you got that. All right. So for right now, I'm not going to do the solution set for this one. I want to get to the one that is called the OR, and then I'm going to show you how to set up the solution set. And then we're going to distinguish one from the other, okay? Here we go. Copy this one, example 5. I touched on this one yesterday very briefly. Today I want to make sure I hammer this out really well and everybody understands how to solve and write your solution set from this. And it reads, example 5, 8 plus t greater than or equal to 7, or 8 plus t less than 2. I'm going to do the first inequality in red, and the one on the right I'm going to do in blue. All right? So with that said, check this out. I'm going to start with this one. Line down the inequality symbol. So tell your neighbor to leave t by itself. What would you do for that one? Yeah, subtract 8, and we end up with t greater than or equal to -1. From there, I want you to bring down the word or. And now let's solve the second inequality, because they're compound. So I'm going to do that in blue. And once again, what do we do to leave t by itself? -8 minus 8. We end up with t less than -6. All right. So let's do a number line down here really quick. So since I have both negatives, I'm going to put my 0 to the right side, since both are negative, so we have plenty of room. So here we go. Since I already have this one in blue, I'm going to graph this one in blue, this one right here. All right? So I start at what? Negative 6 is my dividing point. Open or close point? Open, because it doesn't have an equal sign, okay? I'm going to test 0. Is 0 less than negative 6? No, that's false. 0 doesn't work. So if I'm not going towards 0, I'm going to go in the opposite direction. All right, let's take the second one in red. My dividing point is negative 1, which is right there. Open or close point? Close, because it's got the equal sign. There it is. All right. So I'm going to test 0. Is 0 greater than or equal to negative 1? Yeah, since it's on the right of that number, it is greater, so I'm going to go towards 0. All right? So this is what I want you to do. In this empty space in between, I want you to write the word or. Anytime you see two graphs that do not intersect, that they're going in opposite directions, they're called what? Or. Okay? Now, check this out. Let me go back to the first two that we started with today. Look up. Look at this one. And look at this one. You guys notice that both intersect. Okay? These have a name as well. These are known as and inequalities, and compound, because the solutions are this and that. However, these are known as solutions of or, because the solutions are this or that. All right? So here goes the solution set. Pay attention to this part, because this is where some of you get lost. Here it goes. Write your utensils down, look up to the screen. I'll have you copy it in a little bit. I want to start with my solution set. Solution set, T, such that. Okay, ready? Here it goes. Look up, please. What do I have here? The shaded region. What does that represent? The variable, because we can substitute any of those values there. What goes after? The dividing point, negative 6. Next, what do I have next? Or. Next, what's next? The dividing point, negative 1. What does this represent? T. All right, so now all I need is arrows. To the left, to the left. Which one is a solid point? This one, so this one has the equal sign. Copy that, please. In case you got lost, here it goes. This shaded region is T. The dividing point is that one. You can switch it, but I'm trying to lay it out as we read it on the graph so that people don't get confused. And then this one, then this one, then this. All right. Let's do another one. Let's do this one together and go a little bit faster, but when we get to this portion, we'll go a little slow to make sure we got it, okay? All right, here we go. Example 6. 4x less than or equal to 20, or 3x greater than 20. 4x less than or equal to 20, or 3x greater than 21. So I'm going to do, once again, this side with red and this side in blue. All right. Give you a head start. Let's see what you get. All right, show your neighbor really quick before you finish where you're at. See if they're on the same. All right. All right, help me out, William. What do I do? Divide by 4, so we end up with x less than or equal to 5. Or, continue. Divide by 3, x greater than 7. Hands, have you got that? Yeah, that is correct. Okay, let's graph this. Since both of them are positive, that means my 0 is going to go towards the left, so it can leave me space over here. All right, so I'm going to start with the blue one. 7, open point. I'm going to test 0. Is 0 greater than 7? No, it's false, so I'm not going towards 0. I'm going to go in the opposite direction. Next, 5. Solid point, or there you go. I'm going to test 0 again. Is 0 less than 5 or equal to? Yeah. So that one I am going to shade towards 0. There it is. Do we have a gap in between? Yes. That's why this is a what? Or. Okay. Now let's see how we did with the solution set. Ready? Here it goes. I'm going to start with my solution set of x such that. All right. So I'm reading this graph from left to right. What's first? This shaded region. What does that represent? X. What's my dividing point for that one? 5. Then the word or. What's next? 7. And what is this? X. And then arrows to the left. Which one's a solid point? The 5. And there it is. From 1 to 5, how comfortable are you with these? Yeah? 5 fours, 5 fours? Yeah, we got this. Yes? Yes. Yeah? Oh, you said 6. Oh, okay. Wow. All right. So, I think we got this. Yes? So, no more of these. Let's go to the funner ones, yeah? Copy this one. Example 9. Number 9. And actually, these are so easy, but since they don't give you a lot of information, it makes it kind of like your noodles kind of like trying to go at that pace. My goodness. All right. Oh my goodness. All right, there it is. Copy that graph, please. And we'll do this one together. All right. So let's see. Before I get started, tell your neighbor what kind of compound inequality that graph represents. What kind of compound inequality does that represent? There's only 2 types, right? So which one is it? Yeah, that is correct. This is an and, because there's no gap in between. Therefore, for these, when they give you the graph, all you have to write is your solution set. So go underneath and write solution set. Do they give us a variable? No, that means you can use whatever variable you want. I'm going to use the variable Q. Variable Q. My goodness. No, it's because I'm recording and then that's going to sound on the, you know what I'm saying? It's going to come out anyways. Such that, all right. What's next? Dividing points. What is it? -2. What's the other one? 5. What goes in between? Q. Arrows to the left. Check to see if there's any solid points. Any solid points? No. So we're done. Piece of cake? Yeah. Choco flan. All right. Let's do another one. Copy this one, number 10. Tell your neighbor which compound is that? Yes, or. Give some time for that. Hurry up, and we'll do that together. Here we go. So we said that this is a what? Or. So I'm going to write in here or, so that I know exactly what I'm looking at. So then solution set. Do they give us a variable? No. I'm going to use Q such that. All right, question. What does this shaded region represent? The variable. What's the dividing point? -3. Then or, then 2, then Q, arrows to the left. Do we have any solid points? Yeah, both of them. This one and that one. Bless you. Fairly simple, yes? From 1 to 5, how comfortable are you with these? 5 fours, 5 fours, okay. Do one more, here we go. Don't copy this one, just write me the solution set. Example 11, don't copy the graph, just write the solution set. All right, let's see. Lonzo, what variable are you using? X such that. Close. What is this? X, -8, or 0, X, and then arrows to the left. And this one's a solid point, and we're done. Check your solution set. We got this, yes? From 1 to 5, how comfortable are you with these? That's your home plate for tonight on that play sheet, numbers 1 through 10 only. Make sure you go to Canvas, get that done, and make sure you do it on a separate sheet because wink, wink, hint, hint, we might turn that in tomorrow. All right, I'm going to stop the video right here. Have a good one, guys. See you guys tomorrow. Bye.